one can get more excited than one gets.
Hi, hello, and welcome to Coffee Literature Review. My name is Chris Hendon, and today we'll be discussing a paper published in the journal Analytical and Bioanalytical Chemistry, published this year, 2024. The article's title is The Development of a Coffee Bean Certified Reference Material for Elemental Analysis. This is an important topic and an important development in the scientific literature because reference materials are used to help us calibrate our instruments so that we can then apply those instruments to a measurement of some unknown composition. In this case, we're looking at heavy metals in green coffee materials, which is obviously important for a variety of reasons. For this episode, I'm very lucky and very grateful to be joined by Kyle Glanville. Some of you might have known him if you were one of the 400 or so undergraduates that attended the Cornish College of the Arts.
Right.
To date you slightly, you departed the Cornish College of the Arts when Usher's "Yeah" was #1 on the billboards. The Super Bowl
That's what caused it.
That's what caused it.
I gotta get out of here.
Yeah.
Felt it.
But after that, I guess you spent some time in intelligentsia and then went on from there to start Go Get 'Em Tiger and GMB, where you still are today. Kyle, welcome.
Thank you so much. It's a pleasure to be here.
How often do you get a chance to dive into the scientific literature?
I never do.
Oh, perfect. Well, then you're
I never do. I mean, I have a copy of the Illy book, if you remember that old thing.
Yeah, I got one over here somewhere. Yeah.
There we go. You know, it's sitting on my shelf. They kind of lost me at the, when I realized the whole purpose of that document was to justify the concept of shelf-stable coffee.
Mm-hmm.
I scanned a few of your papers, but these things are like an ADHD nightmare, and that's...
yeah. Can you imagine having to write them professionally? It's very challenging.
Absolutely.
Can you name another graduate from the Cornish College of the Arts that anyone might know?
Brendan Fraser.
Indeed, the Mummy.
Yeah, and then sorry, go ahead.
Yeah, he graduated in 1990. I actually don't know what the #1 song in 1990 was.
In fact, he did not graduate.
Ooh.
He left early. And because I was also in the theater program, that BFA program, the teachers that had been there in 1990 were very, would love to talk about Brendan Fraser and his, magnetism and, Hollywood style. So, he's Cornish's #1 guy.
Well, I don't know about that. I think I'm with it.
We'll see. Yeah,
all right. And
I'm gunning for him.
Also joining us is our producer behind the virtual glass is Doran Pennington, a graduate student in my research group, a recent filter coffee convert, and
thank God.
Yeah, exactly, and generally an all-around extremely valuable member of the scientific community. Doran, are you here with us? Okay, good. Now, before we get into the paper, I actually want to give you a sort of an overview of how this is an unusual paper, but also how you might think about reference materials. So first of all, unlike most research papers that have a stated hypothesis and then go on to present data and basically experiments where you try really hard to discover something new or observe something or explain something in the universe, papers that detail certified reference materials are dissimilar to that in the sense that they spend the majority of the time trying to demonstrate or prove that they are able to make a very precise measurement of the composition of that reference material. And so in some sense, this is quite a dry paper because you prepare something and then you make a bunch of measurements to ensure that you've actually made the thing you said you made. Now, this is actually really important. We'll talk about the coffee bean material in a minute, but thinking about certified reference materials more broadly is an extremely valuable and worthwhile endeavor. I'll give you a couple of examples. There has recently been a certified reference material for human urine, and it's used to make sure that tests that we perform on human urine for kidney function are actually measuring the correct amount of proteins and other composition that comes out in human urine. So indeed, you can spend a tremendous amount of money to buy a very small pot of human urine from NIST. There are other examples as well.
Don't tempt me with a good time.
Yeah, I know. Yeah, you want to drop some serious money on a 25 milliliters of human. You're welcome to.
I wouldn't be the first.
So this paper though, is basically saying, okay, we're going to make a reference material for a coffee, a green coffee powder, and we're going to monitor the composition of heavy metals contained within. Let me send this first question over to Doran. Doran, do you want to expand or unpack this idea of a reference material and perhaps why it's useful to have different matrices that would host these metals?
Yeah, so a big component of reference materials is they act as a model for some complex sample matrix. In our case, it's coffee. It could be a food or human urine, something with a lot going on in it. And the different tests that you do to make measurements on these materials can be complicated by the fact that the matrix is complicated. We all know that whenever you brew coffee, you don't pull out every single extractable molecule from that coffee beverage, from the coffee bean. And it's a similar case whenever you're doing elemental analysis. You want to make sure that if you're making a measurement of, say, iron, that you got every single atom of iron out of that sample so that the measurement's precise. So you can see in this paper that their process for getting these elements out is dissolving the coffee in concentrated nitric acid and microwaving it at 220 degrees C for nearly an hour. So it's important that you model the actual matrix that you're trying to make your measurement on, because you need to make sure that this process is sufficient to extract everything out.
Kyle, when was the last time you brewed coffee in nitric acid in a microwave?
I have microwaved coffee, actually. That was an experiment that I did once.
How'd that go?
Microwaving green coffee, not the beverage, but actually green coffee. That third crack just sneaks right up on you, man. I gotta tell you.
Take that, those who say 80% to development time or whatever. But
anyway.
Okay, so this paper though, let's go through this a little bit. So in the paper, the authors go on to purchase a bag of green coffee and then do a variety of things to it. And I think one of the things that jumps out at me is they elected to buy 20 kilograms of a Yirgacheffe Ethiopian coffee. If my memory serves me correctly, they go on to freeze dry it as whole beans or perhaps as chunks, and then they continue to do various processes to inevitably arrive at a matrix that is basically a dust. They've ground it down to sub 50 microns, so like way smaller than espresso grounds. And the idea here really is that you need to make a coffee reference material that has the same material properties that is representative of all coffee material. So, Kyle, do you think that this arbitrary Yirgacheffe coffee is going to behave when you try and extract from the green? It's a green powder. When you're trying to extract from it, it's going to behave the same as, let's say, a green powder of a Pacamara natural or a you name it,
Robusta.
right? Robusta, right?
Yeah, I mean, I think it's so interesting because this is like a thing whenever like a specialty coffee person reads like coffee science, it'll be like, coffee is bad for you because of all the sugar. And you'd be like, what the are you talking about? Like,
no, you're good. You keep going. I'm just I'm just giving you
the ding, right?
The ding. You got the.
And there's I think it probably serves the science community well to think of it as like this sort of monolith, like there is one coffee is coffee.
Yeah.
Right. And it's hard for me to wrap my head around that, because no, Yirgacheffe is not like every other coffee.
Right.
It is, first of all, it's the birthplace of coffee. It grows wild. Most of the varieties are not even classified. Like, you don't
heirloom varieties, right?
Yeah. And, wildly, wild variation in like bean size and all these things. And so it's hard for me to imagine that this like, densely floral, special, lemon, sweet, complex coffee is chemically identical,
to
a catamore grown at 800 meters in Brazil.
Exactly. Not to mention even the processing methods, which we know definitely do something to how the coffee behaves, right? Anyone who's roasted green coffee, which is not me, but anyway, I've been told that if you roast naturals, they behave very different in the roaster to that of a washed coffee. And I could be wrong, but I don't think they detailed whether they used a natural or washed, but one would assume a washed coffee, but
I would definitely assume, but yes, I was just thinking about this whole like this was the first thing that really stood out to me It's like, okay, well, like you fucking chose caviar, like great. Yeah.
Yeah, yep. Well, they did choose my favorite, so I'm obviously inclined to really enjoy this paper. So,
Yeah.
okay, so let me unpack the method that you use to actually make the measurement for heavy metals in this particular matrix, and then I'm going to sort of relate that to a few other things. So basically, you have this device that burns a very hot flame, essentially, to take all atoms that exist in molecules and turn them into free atoms. The process is called inductively coupled plasma, and then measures the charge associated with those atoms via mass spec. So it's called ICP-MS. And what you do is you basically expose a sample to this plasma, and then you're going to let those atoms that are now charged fly, and you're going to measure basically the time it takes for them to hit the detector. It's not exactly that, but more or less you get the idea. And okay, so when you're going,
the nebulizer, the glass cyclonic chamber, and the
exactly.
nebulizer. Yes. Yeah.
Yeah. And so when you're going after heavy elements, you do run into this challenge that they show up in lots of different isotopes. I'll give you an example. So lead 208 is the most abundant, most stable isotope of lead, but there are other isotopes that exist. So I think lead 208 is at 52%. If you have a handful of lead, 52% of those are lead 208. There is also lead 206, which is quite stable, and it makes up about 24% of those atoms that are in your hand. Lead 206 has a half-life of 4.5 billion years, which means after 4.5 billion years, half of the atoms you were holding that were lead 206 are no longer lead 206, but something else. Okay, so 4.5 billion years is a long time. So we don't need to really worry about the composition of lead changing all that much in like our lifetime. But what we need to be able to do is to be able to measure lead 208 and lead 206 and know that the relative ratios of those matches that of what we would expect in sort of equilibrium in the universe. And this presents as a challenge because some things weigh the same, but are different atoms because of the different isotopes. And so they're going to convolute over one another. So you have to actually do a bit of mathematical trickery and add in some extra mercury and extra lead and so forth, so that you're able to say, oh, there's actually this much mercury naturally occurring in this coffee, this much lead, and so on. So this paper basically spends like, I don't know, 4 pages of its effort showing that they're able to make the measurement very carefully. But there's a few things that jump out at me. Doran, in like, for example, figure 1, which was their basically their reproducibility or their ability to make some measurement on 9 different metals that occur, there's some deviation between samples 1 and 12, of course. Can you tell us more about that?
Yeah, so over the course of their measurements on 12 different samples of this material, some of them they have to leave out because they say that they're too variable. Some of them, if you look at the nickel case, they seem pretty consistent except for one that's nearly 100% more than the other samples. And so in the paper, they make the case that this is because they're using a really forceful grinding apparatus, which is composed of stainless steel. So the mixing elements are stainless steel and coffee is hard. And so they're saying that it's likely that some of that could have flaked off into their material. And there's one specific part of their coffee reference material that has more nickel than it should. So that precludes nickel being used as a standard in this measurement. So if you buy this coffee reference material, you can't use it to make claims about nickel. Stainless steel is composed of nickel as well as iron and chromium.
Yeah.
And their iron variability is a little high. They're not making measurements of chromium in this case, but you wonder if that would also be affected if stainless steel is coming off into their material.
But you're touching on something pretty important, right? Is that certified reference materials have extremely tight tolerances. And the reason that they need to have these is because some places, like, for example, Korea and I think other countries like Brazil, regulate the amount of heavy metals that show up in these products. You know, in America, we don't have that, right?
Well, yeah. Mm-hmm.
So, well, okay. When was the last time the FDA came to Go Get 'Em Tiger and said, hey, have you monitored the amount of mercury that shows up in your cold brew? Never.
It has never happened.
It will never happen. As it turns out, Doran, does the FDA have guidelines for food stuff at this moment?
They do not.
Okay, good. Moving on. So while this is not overly useful in America today, this is a useful thing to do. And obviously there's good reason to go after this. Because they care so much about composition, they say, oh, maybe a little piece of nickel flaked off our stainless steel apparatus. They take a lot of care in making sure that every single thing that touches this coffee material is clean, including the glass that it is sold in. Doran, tell me about that.
So they sterilize the bottles that they use for storage of this coffee reference material by dosing it with gamma rays from a cobalt-60 source. Cobalt-60, unlike the elements that Chris was talking about, is very unstable. It will decay and release gamma rays. And they give it a dose of 25 kilograys. And I'm a chemist that doesn't interact with radiochemistry very often, so I had to look up this measurement. And I found that standing next to the Chernobyl reactor core as it was undergoing a meltdown for 10 minutes will expose you to 0.05 grays. So we're at 25 kilograys. So this is a huge dose of radiation to sterilize the storage bottles.
They should not have done that. This seems bad.
The good news is it's Kyle, it's by the time you receive it, it's no longer it's no longer radioactive, but it is clean. It's very clean. They're so all of this together, I think the culmination of the paper is actually summarized in basically in table 1 and subsequent figures. But they basically say, like, look, if you buy the certified reference material, we can guarantee that this material contains zinc in this concentration, cadmium in this concentration, mercury in this concentration, and so on and so forth. But one of these values really jumped out at me, is this mercury value at 0.1 milligrams per kilogram. Doran, correct me if I'm wrong here, but that is in the vicinity of a mercury concentration that you might find in like predator fish.
Right. So normal coffee samples contain almost always no detectable mercury. So they're spiking mercury into this reference material so that you can then state with certainty that your procedures, your devices, your instruments are measuring mercury accurately. So if you ever do come across coffee that you suspect might have high levels of mercury, you're able to use this reference material in aiding you to make that assessment. But it's orders of magnitude off of almost all coffee samples that you would ever purchase or come across.
Kyle, does that make you feel better?
Yeah, it does. It does. I was reading the mercury stuff. I mean, honestly, and the stainless stuff, and I was like, really? The stainless argument, it felt very suspect. And then I think it was right around then that I actually realized, oh, they're trying to sell me this CRM, like at the end of the day, you know?
Speaking of which, I did source, or I got a quote, I should say, for to acquire some of this CRM, because I think they only made something like just over 1,000 vials of the stuff. Contained within each vial is like 15 grams of material.
Wow.
Kyle, what's the most expensive coffee you've ever purchased?
Most expensive coffee we purchased was $50 a pound. And that was good stuff.
$50 a pound. Yeah. So this one, hold on, we got to do a bit of quick mathematics here. Doran, can you do the math real fast for me?
Yeah, well, one 15-gram bottle is $300 unit price, but including packing, customs clearance, and a CRM report, which is translated into English from the Korean, because this is a Korean institute, the total comes to $500 for 15 grams.
Okay, well, if you're just going for so if you're just going for the green coffee price alone, I did a quick calculation. It's $20,000 per kilo. So we looked at getting some, but I just couldn't justify. Also, not to mention, it also has 1,000 times more mercury in it than any other coffee. So it's not exactly high on my list of like must-haves, but nonetheless.
It's a spicy one.
Yeah, it was like, so what, they made it and then what, they use it because they mentioned earlier in the paper, they're like, these German guys made some roasted coffee CRM and then they ran out. So we were like, oh God, we need to make our own. That's kind of what I read. Like, is the deal like you buy this now or they run out and then somebody else is going to have to come and publish a paper about how they develop the next CRM?
You've actually summarized very nicely why there's a paper at all. Is that this paper exists so that when they run out, someone could remake the CRM and hit all of the exact same metrics again.
There we go.
Now, the paper itself was actually published through KRISS, which is the equivalent of NIST in the United States or INISA in Europe. It's the sort of the Standards Institute. So it's a governmental body, and you, of course, they're making money, quote unquote, but they're not really, because it costs a lot of money and a lot of effort. It's 5 people or whatever went into making this reference material. So it's I think they're kind of breaking even. It's not really like this is not an exercise in making a profit off of these things. And there are like some other famous reference materials that are quite expensive. Doran, you remember some of them?
Yeah, a big famous one is NIST sells a standard peanut butter, and 3 bottles of it, like 3 normal peanut butter sized containers, is about $1,000. And in that case, similar to this one, it's if you have a high fat food matrix and you want to understand concentrations of different micronutrients, you have to make sure that you're getting those out. So that's the purpose of that. They do tend to be expensive because they're made very traceable, and this paper has a paragraph at the end detailing all of the things that go into making a traceable reference material, and it is complicated. You need to have calibrated balances, calibrated instruments. All of your materials need to come from a well-defined source. So it is a lot of effort to make these things.
There's only so much you can say about certified reference materials. So so I'm going to send it to you, Kyle. Yeah, give us your
I have a
comments.
question. I mean,
Yeah.
I'm trying to think of the practical application here, right?
Uh-huh.
So you have the certified reference material, which you can analyze using your instrumentation in a lab if you are smart in that way. And but like what is this like a guide for like how to analyze another coffee to see if it is contaminated or somehow off the charts? And are you supposed to follow this procedure to create your reference? Like I guess that's the part that's not totally clear to me.
Yeah, so very few laboratories in the world are actually certified to make the type of measurement that these ones are making, in the sense that, imagine there's like some litigation situation happening where someone is accusing someone of producing a product that has too much mercury in it for a green coffee sample. Okay. Well, if you went to court and you just made a mercury measurement, the obvious counter to that would be, well, did you use the certified reference material to prove that your mercury measurement actually was calibrated, or did you just pick a random number and your device was swinging off the chart for some reason, like you had a mercury contamination? Which actually, by the way, mercury is an interesting one, right? Because what happens with it?
Yeah, so mercury in specific for ICP-MS, inductively coupled plasma mass spectrometry, tends to adsorb to the walls of the ionization chamber and into the tubing. So there's a commonly observed mercury memory effect, where after you run, say, a standard that has a high level of mercury, your next couple of measurements will have elevated levels of mercury regardless of what sample you're measuring. So there are methods to clear that out, but it's something that you need to consider. So, it goes into that.
Yeah. But no, don't do this. Don't go and buy green coffee, dehydrate it, then dope in radioactive metals, and then grind it up and then extract. Don't do that. If you need this certified reference material, then our $20,000 per kilo price is a good deal. Because if you need this is the only place you're going to get this thing, and it's going to behave exactly as this paper has detailed. Otherwise, there's not much purpose for the average consumer, the average coffee professional, to have this, other than simply knowing that it now exists, which is a good thing, because now we can point to it and say, like, oh, if I'm trying to take a product to market in Korea, I'm going to need to know that I have to hit like certain, cadmium content in my, be below a certain cadmium content in my hot brewed coffee that sits in a can or whatever. You get the idea. So there is some value in it, but generally it's going to be by like certification bodies, these labs that actually can make, like a UL lab, Underwriter Labs, or one of these people that make sure that products in the market are adhering to consumer standards and safety standards.
It's interesting because I think the standards in Brazil and Japan and Korea that I'm aware of seem somewhat blunt in the way that they are expressed. And one thing I was wondering, like, is in the wake of this, knowing that we have this tool, this capacity to measure coffee in this way, does this lead to a higher degree of regulation? I mean, we know not in the States, because in the States, we just don't give a shit what people consume. But like in other places, does it lead to a higher degree of regulation?
Yeah, I actually should go and do some research. I'm sure the listeners will send emails about this. But I'm sure there are examples where the development of a reference material has then led to better laws and regulations surrounding that type of material, because until you have the reference, it's actually hard to be certain that you're making a good measurement. And that really is the basis for the whole paper. So although this is a dry and unusual paper, and certainly will be dissimilar to the subsequent ones that we'll talk about in this show, Kyle, you've really highlighted actually why we're talking about it.
Yeah. The money that's, interested in coffee is not interested in coffee getting rejected for, lead contamination or whatever.
Yeah, precisely. Yeah. Exactly. All right. Any other thoughts, Kyle, before we close it out?
Yeah, it was really, it took me a while to sort of like actually understand even what application they were maybe sort of hinting at. But something I thought that was interesting, and this has been like, I know a little bit of a field of study, is, how to like automate sensory analysis or predict sensory analysis. And maybe it's not with this because we're talking about metals, but is there a version, or does this somehow sort of lead to, an area of exploration where we can perform sort of sensory analysis, maybe even produce like cup scores, using a machine that sort of evaluates the raw coffee or the roasted coffee in a similar way? Could you see that, or is that just like a bridge too far?
No, well, so it's not a bridge too far. In fact, it's a cool thing to think about. I am sure that there are certified reference materials that are not only for composition, so metal composition, I should say. Now, I am not sure whether there are examples of certified reference materials that also can be consumed besides the peanut butter, yes, but that's still for heavy mineral content. There's a diet cranberry cocktail that also is for metal content. So most of them, even though you can drink some of these, of course, most of them are not for sensory, but there's not really a reason that NIST or any of the other certifying bodies could not venture into sensory. I think the harder part would just be making sure that you identify a way to measure the sensory component that goes beyond the human tongue, because the variability between even me before and after a kebab, tongue's gone. So
or like in the afternoon, my tongue just wants to go to bed.
Yeah, for that purpose, I mean, the things that you're tasting are organic molecules, and for that purpose, you would need a reference material that has controlled amounts of every organic molecule in coffee, and you could imagine that would be quite difficult to do. You know, depends on when it was made, all these things, how it was processed. So KRISS does say in this paper that they also make oyster, cabbage, tomato, etc. So
pork.
they do have
pork. Yeah, pork. I'm interested in the certified reference pork.
A little pork powder.
I wonder how much pork you get.
We'll get a quote.
It's also, can you imagine being a pig, and like most pigs, they just queue up and turn into hot dogs. And then like some pigs get the honorable discharge of turning into a cutlet. And then imagine the one pig who they've selected. They've probably rubbed it down every day, bathed it and whatever. And they've decided, you, my friend, are the reference pig.
That's right. You would wear a little crown that says reference pig, and everybody would know. And all the pigs of the opposite, sex would just be attracted to you.
Yeah. Well, or you in a tiny little vial sold for like $2,000 for 5 grams of you. Yeah. Yeah. And you've actually got me thinking about another thing. It's like, when will we see the farm that produced the certified reference material in Ethiopia advertise, we are the reference for coffee.
Yeah.
You know,
Yeah.
put that on the
We are the
anyway.
baseline.
I think we've said it all. That does it for today's scientific discussion of this paper that concerns the development of a certified reference material for a green coffee matrix. Kyle, Doran, thanks for taking a moment to talk science with me. And for everyone who listened along, thanks for coming along on the ride. If you enjoyed this, please consider following us on Instagram or on X. Our handle is CoffeeLitRev. Until next time, bye now.